Okay, so in this short little summary, we're going to finish off our Microbiology of Disease workshop, looking at the normal flora and Clostridium difficile. Now, the aim of this session were to try and begin understanding the process of colonisation resistance, specifically related to the organism called Clostridium difficile. So, in order to do that, we've considered, as part of the workshop, all the factors potentially that can affect the composition of the gut microflora. And as a consequence of disrupting those, we can potentially put ourselves at greater risk of developing infection by the organism Clostridium difficile. Okay, so we went through various areas. Now, rather than put back up photos of all of your notes, I've decided just to summarise those. There was the odd error within them, so I didn't want you to take those errors away with you. And these are the salient points. Now, we first looked at age and the normal microflora. And the important thing to note here is that there is extensive individual variations between different people in terms of what the structure of their gut microflora is. The total counts of microorganisms within the colon of individuals are generally very similar, but it's the composition of that gut microflora that is very, very different. And even within an individual, over time, if we sampled an individual over a period of weeks, we would see variations within the gut microflora structure depending upon the diet and stresses and antibiotic therapy and all those things that we talked about as part of this workshop. Now, in terms of age and its link to the composition of the gut microflora, what we discussed in the workshop was that elderly people tend to have greater numbers of facultative anaerobes and Clostridia, and corresponding reductions in obligate anaerobes such as bifidobacteria and Bacteroides. Now, we talked about the way this reflects the gut microflora that we might expect to see in babies and especially newborn babies. They have more facultative anaerobes than obligate anaerobes, and that has big consequences in terms of the colonic environment. Particularly bifidobacteria are seen as being very friendly organisms. They're very beneficial for our health and very good at stimulating our mucosal immune system. And that's why we tend to see them being incorporated in probiotic therapies and probiotic drinks, yogurts, etc. And they're seen as a very beneficial organism. It's not necessarily just a reduction in number of those particular organisms, the Bacteroides and the bifidobacteria. It's a reduction in the diversity as well. So, I mean, we may see a lot greater diversity in younger individuals, lots of different types of species of those particular genera. But we have reduced diversity in the elderly. As a consequence of these changes, we have a change in the metabolic activity within the gut. We have greater degrees of proteolytic activity and reductions in amylolytic activity, so less breakdown of starch to sugars, and from there on to short-chain fatty acids. So we see reductions in short-chain fatty acid concentrations, acetate, butyrate, propionate. Many of those are very, very important for our gut health and the health of our colonic epithelial cells. We have, in the elderly, we have a greater production of ammonia in indoles, and these are thought to be harmful products produced by anaerobes such as fusobacteria and Clostridia. And we tend to also see increased numbers of lactobacilli in the elderly. And these again are seen as beneficial organisms. They're in many probiotics as well, but they're not sufficient to give you full protection, full colonisation resistance against pathogens. Now, if we move on to diet, and the major point that I wanted you to take away from the diet section was obviously that diet's important in determining the structure of our colonic microflora. The nutrients that we take in and those that go down into our colonic ecosystem affect the metabolic activities of the organisms that are present within your fecal material in the lumen of the colon. We talked about preservatives, particularly sulfites, and how these may increase the growth of pathogens. Organisms that are able to reduce sulfate are increased in their numbers. And we can have production of hydrogen sulfide by some of these organisms, which is again seen as a detrimental effect. Hydrogen sulfide is not something that we want in large concentrations within the colon. There was a lot of diet information within those particular references. Now, again, it's the overall points that I want to get across to you. The high protein diet that we talked about, up to 12 grams of protein can reach your colon, and this is digested by the colonic microflora, and it can be converted into harmful products such as amines and phenols, and also can convert it into short chain fatty acids. That should say short chain fatty acids just there and not FAS. Now, depending on where we live in the world, we obviously have exposure to different types of diet, and again this can affect the microflora structure. In general, Japanese diets and Western diets tend to have low numbers of lactobacilli and higher numbers of enterococci. If we have a very high sugar diet, this can slow the colonic transit time and increase the amount of bile acids that go into our colon, and the presence of bile acids can again go on to affect our colonic microflora structure. Organisms like Bacteroides, for example, particularly like the presence of bile, and they can break that down and resist its antimicrobial effects. If we have a low carbohydrate diet, then there's the potential that our organisms could begin to break down this protective mucin that lines our colonic mucosa, and this could then put us at greater risk of pathogens being able to adhere to the colon, potentially greater risk of infection. Now, stress was one thing that we considered briefly. There's much less published information about the effect of stress on the colonic microflora and if that could be a risk factor for Clostridium difficile infection. But we talked about some primate studies that were done several decades ago, and the fact that there was increased shedding of beneficial bacteria when young primates were stressed by taking them away from their mothers. It was lactobacilli that was shed there. Reduced mucin present at the mucosa also during stressful situations. So again, as in the previous point, less mucin could put you at greater risk potentially of pathogens being able to adhere and cause infections. And we considered catecholamines such as epinephrine and norepinephrine, and that in the laboratory they've been shown to directly increase the growth of organisms such as E. coli and Pseudomonas aeruginosa. And obviously stress is linked to the production of catecholamines. So again, we have potential links here, but nothing proven in this area in terms of Clostridium difficile infection. Now, immune status and aging is a very important area, and we know that as we get older that our immune system reduces in its physiological function. We're getting older now, our populations are getting older, so correspondingly our immune function is getting less as we get into the very advanced areas of age. By 2050 there's going to be a third of the population that are greater than 65 years old, and we're going to have a relatively poor immune system at that particular age. We talked about nutrition and how the elderly, due to their particular diet, a reduction in mechanical chewing, reduction in appetite, and all those kinds of things can mean that some elderly individuals can be relatively malnourished. And again, because those nutrients are going down into our colon, this can affect the structure of the microflora. We've got lower stomach acidity in the elderly. Okay, so this can lead to a reduction in our ability to uptake vitamins and minerals from our diet, and again that can have health consequences for the elderly. And the elderly tend to have reduced gut motility, and the transit time for an elderly individual of material passing through the gastrointestinal tract is slower than for younger individuals. They can suffer more from constipation, and as a consequence they can have greater levels of of protein breakdown within the fecal material, and higher production again of phenols and ammonia, which are generally seen to be harmful to us. But all of these changes can affect the gut microflora. Our immune system is continually protecting us. It's continually being primed. We're producing secretory IgA at our mucosa, which is very important in protecting against gastrointestinal pathogens. We're also producing and defending ourselves without the production of immunoglobulins. We produce various antimicrobial peptides, etc., continually as our immune system detects organisms which are present at our mucosa. And if our immune system is deteriorating over time, then the efficiency of this protection reduces. We also, if our diet is changing as we get older and we're producing less short-chain fatty acids, we again may have, we're not going to experience the beneficial effects of those short-chain fatty acids as much as a younger individual may. So our colonic epithelial cells may correspondingly reduce in their health, and again that could put us at potentially at greater risk of developing gastrointestinal infections. Now, the biggest area linked to Clostridium difficile infection is the effect of antibiotic therapy on the gut microflora. Generally, Clostridium difficile infection is a disease which is linked to antimicrobial therapy in the overwhelming majority of cases. And it's not all antibiotics that are at a high risk of promoting Clostridium difficile infection. It's generally a disease of the elderly, individuals over 65 years of age. Now, these individuals may be more likely to be suffering from chest infections and other infections by microorganisms, so they may be more likely to get antibiotic therapy, therefore more likely to potentially suffer from Clostridium difficile infection. But all of those things in that first point are important in determining how extensively an antibiotic affects the gut microflora and correspondingly whether there's a risk of Clostridium difficile infection. It's generally the broad spectrum antibiotics which provide a greater risk of allowing Clostridium difficile to cause an infection. They disrupt a greater array of microorganisms within the gut microflora, both gram-positives and gram-negatives. If an antibiotic isn't absorbed very well from the gastrointestinal tract, if it's taken as an oral, in an oral form, and very high concentrations remain in the colon, this obviously produces a very high concentration within the fecal material, and consequently a bigger adverse effect upon the gut microflora. A higher concentration will mean that, depending on how the drug works in the body, so the pharmacokinetics, you see PK at the top of this slide here, that's pharmacokinetics. That's how a drug behaves in the body, where it's distributed to. Drugs that have pharmacokinetics such that we have very high colonic concentrations of drug, it'll take longer for that drug to be washed out of the colon than obviously a drug which is very well absorbed from the colon and has consequently lower concentrations of antibiotics. So all of these things are important in determining the effect of antimicrobials on the gut microflora. Osmotic imbalance I've got labelled here. This is the overwhelming majority cause of diarrhea which you would get following antibiotic therapy. Most cases, about 80% of cases of antibiotic-associated diarrhea are due to osmotic imbalance. And what that means is that antibiotics, because they work non-specifically in the body, they target all susceptible microorganisms, assuming that the drug is present at a particular site. So microorganisms within our colon are killed by certain antibiotics, and as we've said in previous slides, this can mean that we have reductions in certain key bacterial groups, and it may be that these organisms are then not viable and not able to break down, for example, the sugars that we take in as part of our diet. So we can have very high concentrations of sugar remaining within our colon, and the laws of osmosis suggest that where we've got a high concentration of solute like sugar, water will move towards it. So water moves across our gut epithelial lining into our colon and gives us diarrhea. It's nothing to do with an infection, it's just an osmotic imbalance. Talked about reductions in short-chain fatty acids in the elderly, but this can be compounded in individuals who are undergoing antimicrobial therapy. So again, we don't potentially experience the benefits of those short-chain fatty acids. Some of those short-chain fatty acids are also antimicrobial against certain species, so they can provide us with some protection. The consequence of all of these factors is that colonisation resistance is reduced in individuals undergoing antibiotic therapy. In the last point here, we've got some classes of antimicrobial which are particularly linked to development of Clostridium difficile infection. So cephalosporins, things like ceftriaxone and cefotaxime, they're broad spectrum beta-lactam antibiotics that are often given to the elderly for chest infections and other infections of that nature, and they are prime inducers of Clostridium difficile infection. Clostridium difficile is generally resistant to these antibiotics and able to grow quite happily within the colon when individuals are undergoing therapy with these agents. And when C. diff grows, it will then produce its toxins and cause consequent diarrhea. Fluoroquinolones, those are things like ciprofloxacin, amoxifloxacin, and those kinds of antibiotics. Again, they are linked to C. diff infection. C. diff can be resistant to them. Aminopenicillins are also linked to Clostridium difficile infection. Clostridium difficile is generally not resistant to aminopenicillins, but what they do is they reduce key components of the gut microflora, and eventually, once the concentration of aminopenicillins has declined sufficiently within the colon of an individual, when it gets below an inhibitory threshold, Clostridium difficile can then begin to grow and produce its toxins. The last antimicrobial class linked to C. diff infection are the lincosamides. These are antibiotics such as lincomycin and clindamycin. And these were the first antimicrobials that were linked to development of Clostridium difficile infection. And again, Clostridium difficile can be resistant to these antimicrobials, but they can often be sensitive as well. Therefore, in a similar way to aminopenicillins, C. diff generally will remain within the colon until concentrations go below an inhibitory threshold, and then the organism can grow and produce its toxins. Some of these antibiotics can disrupt the gut microflora for many weeks after a dose of antibiotics has finished. Therefore, provide a longer window in which Clostridium difficile can potentially cause infection. Okay, so those are the points that I wanted to get across to you. If you've got any questions about them, then feel free to contact me. There's a final slide here, just really to sum up everything that we've talked about, the importance of the microflora and how it's protecting us against not only Clostridium difficile but other pathogens as well. We've got all of the factors that we've discussed as part of this little session. All of them potentially could contribute, but the major factors are age and antibiotic therapy in terms of Clostridium difficile infection. We can think about treating Clostridium difficile based upon what we know about colonisation resistance. Normally, Clostridium difficile infection is treated with more antimicrobial therapy. Now, this can cause us problems because if the antibiotics we're using to treat Clostridium difficile infection then go on to disrupt the gut microflora for a greater period of time, that again puts us at risk of having a recurrence in C. diff infection. So there are new therapies now which aim to restore colonisation resistance within the human colon. Therapies such as fecal replacement therapy is becoming very popular for individuals who are suffering multiple recurrences of Clostridium difficile infection, and this essentially involves transplanting fecal material from a healthy individual into the colon of an individual who is undergoing recurrent episodes of Clostridium difficile infection. Now, there are potential risks in doing this if you are treating somebody with a biological organism, and the same goes with probiotic therapy. Again, there are risks there. If you have an immunocompromised individual, are you increasing potentially the likelihood of them developing, for example, a bloodstream infection with the organism that you are treating them with to try and get rid of your Clostridium difficile infection. So there's a balance here that clinicians have to weigh up.